All right. In this video, the last in a four-part series on parallel, perpendicular, and oblique lines, we're going to be given a triangle. We're going to be given the vertices of this triangle. We're going to want to find the equation of the side AB. We're going to find the perimeter of the triangle. This should be correct to two decimal places. We are going to find the interior angle B, corrected to decimal places, and then I'm going to find the exact area of the triangle. So in the first question, A is given, the vertex A is at -4, 5, vertex B is at 4, 19, the vertex C is at 8, -5. Now for this type of question, it's going to be highly recommended as usual to make a sketch of the situation. Okay, so coordinate A is at -4, 5. So this is A, -4, 5. Coordinate B is at 4, 19. It's in the first quadrant. The y coordinate is much bigger than 5, so it's going to be I think let's put it there, 4, 19. Coordinate C is at 8, -5, which is going to be in the third quadrant. The question is it on the left hand side or on the right hand side of B? And since the x-coordinate is 8, this one, the x-coordinate is 4. It's going to be towards the right. So I'm going to put it there, 8, -5. Okay, so that is our triangle sketch of it. So this is a sketch, but it's going to give us enough information to guide us as we go through the calculations. And so the first question, we want to find the equation of the side AB, which is this one here from our sketch. You can see that this should be, this is upsloping. So let's get going with that. So part 1. So the first thing we're going to want to do is to find the gradient of AB. So we're going to do y2 minus y1. It's y2 minus y1. I'm going to do x2 minus x1. 4 minus -4. 19 minus 5 is 14. This is 4 plus 4, it's 8. So this is going to be 7/4. Okay, then using the 1-point form, equation is going to be y minus y1. If we use this point, y1 is 5, and then equal to 7/4 x minus x1. So it's going to be x minus -4, which is x plus 4. So this is going to be 4y minus 20 is equals to 7 into x plus 4. If we remove the brackets here, this is 7x plus 28. If we bring the 7x to the right left hand side, then this is going to be Just one moment. Yeah, so then this is going to be 48 this side. So that's going to be the equation of the side AB. After that, in part 2, we want to find the perimeter. So if we start with the side AB, we are going to do x2 minus x1 squared, y2 minus y1 all squared. So we're going to have 4 minus negative 4 squared, 19 minus 5 all squared. So 4 plus 4 is, so it's going to be 8 squared plus 14 squared. Then if we punch this in the calculator, so 8 squared plus 14 squared, this is going to give us 260. So at this point we don't evaluate this, we just keep it as square root 260. This is to minimize rounding off error. We're going to do the rounding off at the very end. Then for side AC, so we're going to have 5 minus negative 5 all squared, negative 4 minus 8. So we have got 5 minus negative 5 all squared, 4 minus negative 8. So this is going to be 10 squared plus 12 squared. 10 squared is 100, 12 squared is 144. So there's going to be 2 square root of 224. Then BC, the side BC, so that one we're going to have 19 minus negative 5 plus 4 minus 8 squared. So 19 minus negative 5 squared, 4 minus 8 all squared. This is going to be 24 squared plus 4 squared. Okay, then again, so 24 squared plus 4 squared is going to be 592. So write that as square root 592. And so now we can do the perimeter. So it's going to be square root 592 plus square root 244 plus square root 260. So, and then at this point we punch this in the calculator, and then we can round off. So we're going to have square root of 592 plus square root 244 plus square root 260. And so this in decimal form, 56.08. So that is going to be the perimeter of this triangle. Right, then in part 3 we want the interior angle B. So that means in this case we want this angle here. Now that angle is made by the sides AB and BC. So that means what we're going to do is we're going to need the gradient of BC. So So MBC, we already have the gradient of AB. The gradient of BC is going to be 19 minus -5 divided by 4 minus 8. So 19 minus -5 divided by 4 minus 8 is going to be 24 over -4. This is going to be -6. This is in agreement with our sketch, which shows this as downsloping. So the idea with this is we are going to extend AB, and then we're going to use this triangle to work out the value of theta. If we can find this angle and this angle, then we can find that angle there. Right, these two angles here depend on values of the inclination angles of the lines AB and BC. So let's start with AB. So what I'm going to call theta AB is going to be inverse tangent of the gradient of AB. Remember, the gradient of AB is 7 over 4. So if punch that in the calculator, inverse tangent 7 divided by 4, so that's 60.255. It's less than 90, 60.255. And looking at the line AB, that must be that angle there. So I'm just going to put here inverse tangent 7 over 4. Then for the line BC, the gradient is -6. So I'm going to do here theta BC inverse tangent -6. Punch that in the calculator. Inverse tangent -6 gives us -80.54. So just looking at the sketch here, BC makes two angles with the horizontal. This one is obtuse. It's only this one that is acute, so that angle must be this one. But here we are not interested in the sign, because we say the negative simply means that the angle is on the left hand side of the line. So otherwise, but we're just interested in this one. This one is just positive 80. It's just 80 in terms of that triangle, and that 80 is given by simply tangent of 6, inverse tangent of 6. So what we have now is that the inverse tangent of 7 over 4 plus the inverse tangent of 6 plus theta is equal to 180. Okay, so let's just confirm that here. We just do inverse tangent 6, then you get that angle as a positive value, not negative. So what we want to do here is we're going to write theta plus inverse tangent 7 over 4 plus inverse tangent 6 is 180. So theta is going to be 180 degrees minus inverse tangent 7 over 4 plus inverse tangent 6. And then we punch this in the calculator, and then at that point we're going to do the rounding off. So 180 minus open brackets inverse tangent 7 over 4, and then plus inverse tangent 6. Okay, then this is equal to 39.21. So that is our angle B. I called it theta. Yeah, I can call it. So 39.21 degrees is the value of the interior angle B, right? Then the last thing we need to do is to find the area of the triangle. Now notice here they want the exact area. Okay, before we work on that one, I'm just going to remind you of the trigonometric formula of the area of a triangle. So it says if you've got an isosceles triangle, and this isosceles triangle has got sides A, B, and C, and the angle which is made by A and B is theta. Okay, it's called the included angle. Is theta. Then the area of this is going to be 1/2 AB times sine theta. So theta is the angle made by these two sides. So in our case, we already know this angle here. We know the length of BC. We know the length of AB. So we can use that formula. Now the side AB is square root 260. Since we're looking for the exact value here, we are going to use that square root 260 exactly as it is. The length of BC, we've worked it out, is square root 592. So square root 592. So that means the area of this triangle, we can work out, it's going to be, so the area is going to be 1/2 square root 592 times square root 260 times sine of the interior angle B, which we just worked out above here. But since we are looking for the exact area, we're actually going to use this one here. I'm going to show you just now how that works out in the calculator. Okay, so this is how it's going to work. So if you go to the calculator on your screen, if you've just worked out the value of the angle B, it is now answer to the previous answer. So what we're going to do is we're simply going to say sine of answer. Okay, then we're going to say times the square root of 592, and then times the square root of 260 equal. When you do that, you must always find an answer that is a whole number, and then we're now going to divide by 2. So the area of this is going to be 124 square units. The interesting result is that if you have got a triangle on the coordinate axis and all the coordinates are whole numbers, then its area, it's either going to be a whole number or a whole number 0.5, nothing further than that. So like in this case, it's just a whole number. So that means whenever you do this bit here, exactly, it must always give you an integer. All right, so yeah, so that sorts out example A. We are now going to go to example B. In B, we have A is 3, 4, B is 0, -5, and C is -7, 9. So again, we're going to start by making a sketch of this. So A is 3, 4. So we're going to place it there, 3, 4. C is -7, 9. So it's in quadrant number 2, but it's going to be much higher than this line. So we're going to place it there, -7, 9. B is 0, -5, so it's going to be on the vertical axis below the origin. So that means this triangle is going to look something like that. So again, we're going to find the equation of the side AB. This looks like upsloping. So let's see if the numbers agree. So start with the gradient. So it's going to be 4 minus -4 all over 3 minus 0. 4 minus -4 is sorry, actually this is -5 here. -5 there, so that's going to change this one. It's at -5, so it's going to be 4 plus 5 is going to be 9. It's going to be 9 over 3. So M for the line AB is 3. Then we can use the fact that we already know the y-intercept. So the equation is going to be 3x minus 5 straight away, which we can leave like that. Then we now work on the perimeter. So AB is going to be the square root of, so we are going to have to do 3 minus 0 squared, 4 minus -5 squared, 3 minus 0 squared, 4 minus -5 squared. So this is going to be 3 squared plus 9 squared. 3 squared is 9. 9 squared is 81. So this is going to be square root 90. So that's the length of side AB. Then we're going to do AC. So for AC, we're going to have to do 9 minus 4 all squared, -7 minus 3 all squared. So that's going to be -7 minus 3 all squared, 9 minus 4 all squared. This is going to be 10 squared plus 5 squared, so it's going to be square root 125. Then BC, if we do the same thing for BC, going to have 0 plus 7 squared, 9 plus 5 squared. So this is going to be 7 squared plus 14 squared. So, and then if you punch those numbers in the calculator, that's going to give us 245. So the perimeter is going to be square root 90 plus square root 125 plus square root 245. And again, punching this in the calculator going to give us 36.32. So that's going to be the perimeter. Then in part 3, we're looking for the interior angle B. So again, there we are. That is the angle we're looking for. So the side AB, we already have found the gradient of it. So we need to find the gradient of the side BC, and then we're going to use those ones. Okay, maybe, yeah, so maybe let's just do that one here. So MBC is going to be equal to 9 minus negative 5 over negative 7 minus 0. So 9 minus negative 5. And then here we're going to have negative 7 minus 0. It's going to be 14. So this is going to be negative 2. Okay, now remember the gradient for AB was 3. So maybe let's just do the gradients here. So M for this one is 3. M for this one is negative 2. Then if we do inverse tangent 3, that's going to give us that angle there, because it's the same as this one. So that is going to be inverse tangent 3. This one is going to be inverse tangent 2 if you just make this positive there like we did in the previous question, because we're just interested in the size of the angle. So then if we use this triangle here, then we can do the same thing as before. So then our angle B will be 180 minus inverse tangent 2 plus inverse tangent 3. And then we can punch this in the calculator. Let's do, so we have got 180, especially because we're going to use this in the next question, minus open brackets inverse tangent 2 plus inverse tangent 3. Inverse tangent 3. Oh, and this works out in this case to an exact angle 45. Okay, so let's go back to our sketch. So this angle here is 45 degrees. And then for the area, we just need to know how long this one is. So that's BC. Where is BC here? BC is square root 245. So square root 245. How long is AB? And AB is square root 90. So this side square root 90. So that means the area of this must be half of square root 90 times square root 245 times sine 45. So that's what we're going to do, and that's going to be the last question. So half of square root 90 square root 245 times sine 45. Okay, so remember, we expect this to be a whole number. At worst, if it's a decimal, it must be 0.5. So let's see that works out like that. So we are going to first work out square root of 90 times square root of 245 times sine 45 sine 45. This must always be a whole number like it is there, then divided by 2. So you can see in this case our answer is going to be I think I divided by 4. So it's 105 divided by 2. What is 105? Why do they have 105 divided by 4 here? Okay, I'm going to have to work that one out again. 105 divided by 2. Okay, that's 52.5. It's going to be the area of square units of the triangle. All right, so what we're going to do now is we're going to let you have a go at part C. Just pause the video, have a go at part C. Then when you continue the video, then you can compare with our answer there. Okay, so we hope you have now had a go at this part C. I'm going to scroll down and take you through the solution. So for C, coordinate A is given by -4, 4. Coordinate B is given by -1, 0. C is given by 8, -1. So let's just make a quick sketch of the situation here. B is -1, 0. So B is going to be somewhere here. -1, 0. A is -4, 4. So it's further to the left, but above this one. So -4, 4. C is to the right, somewhere there. 8, -1. So this triangle is going to look something like this. Yeah, so notice that angle B is greater than 90. Okay, so the first thing we're going to do is to find the equation of the side AB. Now from this we can see that the side AB has got a negative gradient. So let's see if the numbers agree with our rough sketch. So MAB. So the difference in y is going to be 4 minus 0. And the difference in x is going to be -4 minus 1. So it's minus -1. So it's going to be 4 over -3. Okay, so which is negative, of course. So then the equation of the line is going to be y minus 0, -4 over 3, x minus -1. So this is going to give us 3y is -4 into x plus 1. So 3y is minus 4x minus 4. So we have got 3y plus 4x plus 4. So that's going to be the equation of the side AB. And then in terms of the lengths, so AB is going to be the square root of -4 plus 1 all squared, 4 minus 0 all squared. this is 3 squared plus 4 squared. This is square root 25. So that's going to be 5. And then AC, on the other hand, going to be 8 plus 4 squared, 4 plus 1 squared. So this is going to be 12 squared plus 5 squared. This is going to be square root 169. So this is 13. Then BC is going to be 8 plus 1 all squared, negative 1 squared. This one is going to work out to square root 82. So the perimeter is going to be 13 plus 5 plus square root 82. So it's going to be 18 plus square root 82, which works out to 27.06. Then in terms of the interior angle B, so as I've already mentioned, you can see that the interior angle B is obtuse. It's greater than 90. So we already have the gradient of side AB. We're going to need the gradient of side BC. So the gradient of side BC works out to negative 1 over 9. Now if you work out negative 1 over 9, so if we just extend this line here, so that angle there is going to be inverse tangent negative 1 over 9, which means it's going to be the same as that one there. Okay, so okay, just one moment, try and rebuild this diagram here. Okay, so what I was trying to say is that this angle here is going to be inverse tangent 1 over 9, and this angle here is going to be inverse tangent, so it's just the gradient we got here, but we use the positive value. Now since we've got a straight line angle here, that means this one here is going to be 180 minus inverse tangent 4/3. So that means we now have this angle B. It's going to be this one plus this one. Okay. So so come back here and say B is going to be inverse tangent 1 over 9 plus 180 minus inverse tangent 4 over 3. We punch that in the calculator, it works out to 133.21, which is of course greater than 90. Then for the area, it's going to be 1/2. Now the sides of interest, so this side AB is of length 5. The side BC is of length square root 82. So when it comes to the area, we're going to have 1/2 times 5 times square root 82, then sine b, which we're going to use this exact value there. Okay, so let's see how this works out. So we have got inverse tangent 1/9 plus 180 minus inverse tangent 4/3. Okay, so there is the 133.21, and then we're going to use this exactly. So we're going to say sine of answer times 5 times square root 82. So remember, that should always give us a whole number. So at this stage, this should give us a whole number all the time. And then after that, we're going to say divided by 2, of course. So that means the area this time is going to be, so the area this time is going to be 16.5 square units. Right, so that brings us to the end of this video. Thanks for watching. Hopefully this has been useful, especially if it has been useful. If these videos are useful, please do subscribe to support our channel, and so that you can get notified whenever we post new material. Thank you.